Alrighty, so in this video for the Pert practice test, we're going to do questions 9 through 14. Alright, so number 9, the perimeter of a rectangular swimming pool is 30 meters. So I am a very visual person. I'm going to go ahead and draw myself a swimming pool. And I know that if I add up all of these sides, which we don't know what the sides are yet, it's going to equal 30. So before I go further, at least I'm understanding what that first sentence was. I knew what the word perimeter means, and I knew what a rectangular swimming pool looks like. All right, so it says the width of the pool is 3 meters less than its length. Okay, what is the width? So it wants us to find the width. And I know that the width is 3 meters less than the length. But I don't know the length either. So once we start figuring this out, I can see, okay, well, let's go ahead and just get rid of this W, and let's just call the width sides L minus 3, because then at least we're dealing with some like terms here, and then this side would be L. So I'm going to set this up as just a polynomial. So we're going to add up all the sides. We have L minus 3 plus L minus 3 plus L. All right, so when you get to something like this, now we're just going to combine our like terms here. So going down the list, my like terms are all of my L's. So when you are combining, that means to add. So we're not going to change the L. When you add, you don't change the variable or the exponent or anything. You're just going to go ahead and combine the front numbers, which is 1, 1, 1, and 1. So we have 4 L's. Our other like terms are these negative 3's here. So again, we're just going to add them together because combine means to add. So negative 3 plus negative 3 is negative 6. I'm going to bring down the 30. So now this looks pretty easy from what you've seen before. We're just looking at a multi-step equation. So let's go ahead and solve for L. I need to move the 6. Sorry. So then these cancel and we just have 4L over here. And then 30 plus 6 is 36. And then our very last step would be divide both sides by 4. And L equals 9. So we want to go ahead and the first thing we want to do is we found that L is 9. And so it's really common to just go ahead and circle the number 9. But let's triple check that that's what it's asking for. It says find the width of the swimming pool. Well, 9 is the length of the swimming pool. That doesn't help me. So don't go jumping into circling 9. Your answer is 9 minus 3, because remember it's 3 less than the length. So your answer should be C. All right, let's go ahead and do number 10. This one doesn't require too much setting up. It's just kind of understanding what 7% is. So Jose's books for the semester cost $432. How much tax will he pay if the tax rate is 7%? Well, to figure out the tax rate of 7%, we need to find 7% of 432. So you can make this an is over of statement, but honestly, the easiest way to figure this out is just do 432 times, and we need to turn the 7% into a decimal. So that's 0.07. Okay? Don't put it in the first spot. That's 70%, but this is 7%. So 432 times 0.07 is $30.24. And that one's pretty easy. It's right here. Because we triple checked. It does just want the tax. It doesn't want the total. So it just says, what is the tax? All right, number 12, to simplify. So these are two terms and we are multiplying them. So what we have to do is when we multiply them, we look for the same things as adding. We look for like terms. There's just different rules. So our like terms here are negative 8 and negative 6. They're just numbers. Then we have x to the 4th and x. Let me get a third color going on here. We have y to the 3rd and y to the negative 7th. So now that I've identified my like terms, let's go ahead and multiply them. Negative 8 times negative 6 is a positive 48. So all I did was I brought over the two blue terms, was what I did here. So now let's do the next one, x to the fourth times x. When we multiply bases, we need to add our cute tiny little exponents, which that's a 1. So this should be x to the fifth, because x to the fourth times x to the 1 power, because that 1 isn't there, but we know it's there, is x to the fifth. Now let's do our pinks, which is y. And then let's add our cute little exponents. 3 plus -7 is -4. Now, we're really close. However, they do not want a negative exponent. So now we're going to go ahead and switch back to our exponent rules. And how you get rid of a negative exponent is you just put it at the bottom of the fraction and it changes. So we're going to leave 48, x to the fifth at the top. And then this y to the fourth comes down here. And now this 4 will magically turn to a positive 4 because it's on the other side of the denominator. So your answer for number 11 would be C. Number 12. Look at me already writing on it. All right, write the number, a big number, using scientific notation. So scientific notation, the things that you need to know is if you move your decimal to the left, so if you move your decimal to the left, your exponent will be positive. Sounds backwards, but it is. If you move your decimal to the right, your exponent will be negative. Okay? So what we're going to do is the decimal's at the end, and we're just going to see how many spaces it takes because we need to move it to the left. So we're going to go 1, 2, 3, 4, 5, 6, and 7. You don't ever go to the very beginning. You always want a whole number in the front. So you should have 3.712, and then we moved it 7 to the left. So I am looking for a positive number. So you should have A. All right, now this is number 13, and so now we're talking about polynomials, but now we're dividing. So dividing uses very similar rules. So when you divide bases, you subtract exponents, but this one is a little bit different just because we have a trinomial at the top and then a monomial at the bottom. So if you think about it as 3 completely separate equations, if it helps. So every single one of these is going to be divided by 3xy because that's what's at the bottom. So if you kind of envision that, and we're going to do this 3 different ways and then simplify. Okay, because that 3xy is going to be shared to everything. So let's look at the numbers. We have 9 divided by 3, which is 3. X squared divided by x. So remember, these have cute little exponents. So when we divide bases, we subtract our exponents. So 2 minus 1 is 1. Now, I do not have to write that 1 exponent because you're not going to see it when you do these. So that is what, you don't even need to look for it. So now let's do y to the 1 minus y to the 1. Well, that gives us y to the 0. And if we think about our exponent rules, right, anything to the 0 power is just 1. So we can go ahead actually and get rid of the y completely. It cancels each other out. So now we're just at 3x. Okay, so we've done this portion. Now let's look into the middle. -12 divided by 3 is -4. And x to the 1 minus x to the 1, these cancel each other out because it's going to give you x to the 0. So we don't have an x to carry over. Y to the second minus y to the 1 is y to the 1. But I'm not going to go ahead and write that. So we don't have to do that now. This one's a little bit different. So in the past, we know that if there's a 1, we don't need to write it. However, in this case, because both the top and the bottom are identical, it actually brings it to the number 1. So because 3 divided by 3 is 1, these x's cancel and these y's cancel. Now, if the variables were still there, we wouldn't necessarily need to write the 1 because it would assumed to be there, but they're not. So we can't just drop off the 1, so it's still there. And they're definitely checking that you know that skill because the B actually has it without the 1. So it's really making sure that you understand your rules here. Okay, so you want to make sure that you're super careful about that. All right, the last one on this video is number 14. So this is subtraction. Subtraction is pretty cool. It's very similar to addition. The only rule is this negative sign gets distributed to everything behind it only. And when you multiply by a -1, you can distribute it, or you can just kind of remember the fact that it's just going to change the sign of everything in here. So I'm going to go ahead and write 7x to the third minus 6x to the second plus 2x. I didn't change that first parenthesis, and we can drop the parentheses too at this point. Now, instead of a positive 5x squared, it's a negative 5x squared. Instead of a positive 8x, it's going to be a negative 8x. Instead of a negative 3, it's going to be a positive 3. So now we're going to go ahead and let's do our like terms, and I am very much a color person, so 7x cubed. So I'm going to go down the line, and I don't see any other x cubed. There's no like terms for him. All right, so I'm going to go ahead and just write 7x cubed. There's no like terms, so it's just going to be what it is. All right, the next one is I'm going to do negative 6x squared, and I go down the line to see if there's any other x squareds, and there are. So now, I remember when you're combining or adding, you keep the variables, everything the same. We just have a -6 plus a -5, which is a -11. All right, let's do another color. So now I have 2x. And now I'm going to go down the line to see if there's any just plain x's that can combine with them. And there's -8. So again, when I combine, I know that I'm keeping the variable the same. 2 plus -8 is, it should be -6. And then this 3 doesn't have anyone to combine with. He's at the end, so you can just add him right there. So right here. And it is checking that you know what you do. If you didn't distribute that negative sign, you actually would have gotten something pretty similar to C. So it's really just making sure that you know that that negative sign distributes to whatever is behind it, and then it changes its sign.